Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hi and welcome everyone to a new episode of our ETAS podcast. My name is Thomas Irmscher. I'm the product manager for cybersecurity testing at ETAS, and I will be your host of this podcast episode. I'm really proud of having two very experienced guests with us today. I'm thrilled to welcome Steffen Sandwald from Mercedes-Benz Tech Innovation. Hi, Steffen.
Hi, Thomas. Thanks for inviting me over. I'm Steffen Sandwald. I'm a security researcher for almost 7 years in the automotive domain. I started as a security architect at a supplier, and now I'm doing penetration tests at Mercedes-Benz Tech Innovation. So I know both sides. I know the defense and the offensive part, and also the supplier and the OEM perspective, and I'm happy to share my personal views on the topic of fuzzing, but they don't reflect the opinion of my company.
Yeah, thank you. Thank you so much, Steffen, and also for taking the time to have the podcast today with us. Additionally, I also like to welcome a colleague of mine, Marcus Cardoso from ETAS Germany. Hi, Marcus.
Hello, Thomas. Hi, Stefan. Thanks for the invite to participate in this podcast. Quick introduction about myself. I have worked since 2004, more or less, in the test and measurement industry. So basically, most of the time of my career, I have been in the tool provider side, with the exception that I have worked 2 years for an OEM, General Motors. But my most experience is in the test and measurement. And currently, I'm the product manager of a protocol fuzzing tool at ETAS called CycleFuzz. And yeah, I'll be happy also to share my view here. Thanks for the invite.
Great. Thank you. Thank you, Marcus and Steffen. So our topic today is about cybersecurity. In detail, we are going to talk about security fuzz testing in the automotive domain. Steffen, could you please briefly explain what security fuzz testing is at all and what role it plays for automotive validation?
Thanks, Thomas, for the question. Yeah, fuzzing aims to test the robustness of software targets. In our particular case, in the automotive domain, these are usually embedded ECUs. For fuzzing, the fuzzer feeds random or invalid data to a target to reach edge cases and provoke crashes. In worst case, those crashes could indicate security vulnerabilities that could be later exploited, for instance, by an attacker. In general, there are multiple approaches of fuzzing. On the one hand, there's protocol fuzzing, which feeds these inputs to the target via the ECU interfaces such as CAN, Ethernet, FlexRay, or whatever. And on the other hand, there's guided source code fuzzing, which leverage the source code to feed inputs to the target. Fuzzing became popular the last few years in the automotive industry caused by the UNEC type approval, where it's explicitly recommended in the ISO 21434 as a part of the security testing methodology.
Okay, great. So this was already a very, let's say, detailed look into fuzzing. Marcus, so Steffen already mentioned it. So there are two types of fuzzing in general. So Steffen mentioned it. The first one is protocol fuzzing. Yeah, and then you just introduced yourself with being a product manager for a protocol fuzzing tool. So I think you can tell us a lot of things about that. And additionally, also Steffen introduced the fuzzing type of guided source code fuzzing. Maybe can you also share a little bit your experiences with fuzzing in general and those two types in detail?
Sure, I can bring an overview about the protocol fuzzing here. As Stefan has said, when we are talking about a protocol fuzzing, it is basically we have the target ECU that can be physical, can also be virtual, but at least what I have seen in the customers today is more physical ECUs. So you connect the fuzzer to this target, to this physical ECU through communication bus, can be CAN, can be automotive Ethernet, for instance, and then the fuzzer started to send messages to the target, as Stefan explained it. What I have experienced or I have learned so far regarding protocol fuzzing is that there are, in the case of protocol fuzzing, there is an interesting advantage. That is the fact the setup is quite fast. Because basically what needs to be done is to connect to an ECU through the bus. You need the minimal information about the ECU, and then you can start fuzzing. That's the term that we use when you're running a test fuzzing. You can start fuzzing. This is an advantage that I have been getting as a feedback from customers, so they can do this the setup quite fast. I even heard from a customer that is protocol fuzzing is the way they used to fail fast because of this setup. This is an interesting feedback that I got.
Yeah.
On the other hand, nothing is perfect in this world. No? When we talk about protocol fuzzing, we are more in a direction of the concept of black box or gray box fuzzing, meaning that you have very few information about the ECU. And the challenge a bit when you talk about protocol fuzzing is that checking the health state of the ECU is more limited. For instance, you send a message to the ECU and you can check if the ECU crashed. You can check if the ECU is stopped responding. You can check if it is a cluster. You can check if there is any light that was blinking but was not expected to blink, and etc. If the power consumption is higher, but those are more limited. So this is what I've seen as a trade-off, at least what I have heard from customers.
It sounds very magic what you explained here. Yeah, so fuzzing sounds really interesting. Yeah, so you mentioned about this quick setups, automation. You mentioned black box approach. So what does it actually mean for cybersecurity validation in general? So we have also other validation methods like penetration testing, vulnerability scanning, or source code auditing. What makes fuzzing here unique or sets it a little bit apart from the, let's say, more manual driven testing methods? Stefan, what do you think about fuzzing here?
I think the key benefit of fuzzing compared to manual pen testing and source code audits is that it's not the usual straightforward way. With this random input, the fuzzer generates, we reach edge cases a normal pen tester usually doesn't think about. Some bugs are deeply nested in the code after hundreds of function calls and occurs only under rare conditions, and that's usually not visible to a pen tester or not on a source code auditor. So the benefit of fuzzing is that it really isn't not structured. It's bringing randomness into the testing. On the other hand, it's not the silver bullet for testing. So fuzzing goes, in my opinion, hand in hand with a pen testing and source code audit of a target.
I fully agree. I would like to just make a comment on the Stefan's definition, if that's okay, Thomas.
Sure.
I heard Stefan from one customer that was doing fuzzing, and was very interesting what he said, because he was doing fuzzing. He had some findings, and on one hand, he was quite happy, but on the other hand, he said, okay, now I need to explain why we didn't detect these findings before, with the requirement-based testing. And what you said was exactly what he mentioned. He said, I see fuzzing as an additional point of view. And that's what you said, going hand in hand. It's not a silver bullet, but it's an additional testing, so to improve robustness. So I just wanted to mention this.
I completely agree with you. For me, I first faced the topic of fuzzing when I was back then studying cybersecurity, and this was at the time when Heartbleed, a vulnerability in OpenSSL, was recently published, and no one saw this in the code. But if you run this in a fuzzer like libfuzzer, RFL, or whatever public open source tool you use, the fuzzer finds it within seconds. There are tutorials that reproduce how to find this vulnerability, and I was quite shocked how easy it was using to find this vulnerability using fuzzing, and no one found it in a project which is used in nearly every exposed server in the internet.
I heard that fuzzing was used in the IT industry before, no? There is. Does anybody? I don't know if you, Thomas, or if
I
you,
think
Stefan, knows about
I
it.
think actually Google started with this, right? And I
Yeah.
think they started with OSS Fuzz, I think, or OSS Fuzzer was the name. And as far as I know, they developed it only for testing their Chrome browser, because Chrome is, as you know, this is a browser for web pages, and a browser has a very high, huge, let's say, interaction with the user. So many data as input, but also a lot of data as output. And I heard that those applications with has a high degree of interaction with the user or with the system, they're very good targets for fuzzing actually. Is this something what you can confirm, Stefan?
Yeah, yes, basically, I think Google started with libfuzzer. That's what the project is called. It's like an
Okay.
extension to the compiler Clang, and they extended it in a way that they started the OSS project, OSS Fuzz project, which consolidates many open source fuzz projects in one centralized repo and pipeline to conduct the fuzz tests. I think that's how they started it. So for the Chromium browser, it's a really good target as it has lots of user interaction input coming from untrustworthy inputs such as websites where actually code is executed on your local machine by JavaScript, HTML, CSS, whatever. So basically you have a whole ecosystem that is running untrustworthy code. And there it makes absolutely sense to conduct as many security fuzz tests as possible.
I have two questions actually. So we heard now, okay, fuzzing makes totally sense as an add-on, right, to other testing methods like penetration testing, code auditing, and so on. What question the one or other listener of this podcast may have is, from where does the fuzzer actually know what messages he should send to the target? So can someone of you both maybe elaborate a little bit on that? So how does the fuzzer generate those messages? And is it totally irrelevant what kind of target you have? So if it's an ECU or PC, what are here a little bit the distinction factors between different fuzzing solutions?
Maybe I can give my point of view as since I work with OneTool, and I would love to hear also the opinion from Stefan as you may interact with other tools. So in the universe that I am inserted now, what I see is people wanting a fuzzer with a high level of configurability. What that means that you can create a boundary conditions of how you want to generate these fuzzing messages. For instance, in the automotive domain, you have a file that is called DBC file. That is the file from the ECU where you have all the CAN messages, for instance. A good fuzzer, you may want to change the arbitration ID of these messages, or you may want to change the data length information of these messages, or you may want to play with the data payload. So you may want to have ways to target your randomization, and then you let the fuzzer create these random messages. Now, or another example that is in CAN protocol or CAN-based protocol, you have what is called UDS services, and then you have different UDS services that is regulated by an ISO, and you want to create random messages for specific UDS services or for multiple UDS services. This is the strategy that we see. We can call it smart fuzzer or pseudo random fuzzing, but the idea behind is that you define the boundary conditions and you let the fuzzer create random messages in these boundary conditions. But as I said, this is the reality that I am more inserted. I don't know if Stefan, if you what you have seen.
Yeah, in my environment, I became kind of an ambassador for guided source code fuzzing, which leveraged the source code of a target as a back channel to that a fuzzer that mutates the input messages knows what inputs and what messages reach what kind of execution path, and then the fuzzer can mutate the inputs accordingly to reach as maximum code coverage as possible to really reach the edge cases of the target and find the crashes there. And when I first tried to run the famous fuzzing tools we know from Google, Microsoft, and whatsoever from open source, I stumbled across challenges from the automotive domain and the supply chain. It starts with, do I have all the provisions I need? Do I have the source code for the target in my position of the supply chain? And if I have the source code, is it complete? How do I handle the hardware dependencies? Usually the code of an ECU runs on a microcontroller, but for conducting fast tests using the state-of-the-art tools like the tech companies, you need to cross-compile it for Linux, and there you have to find ways to deal with the hardware complexities. And in my experience, a good starting point is if you have a project where there are already existing unit tests or integration tests that you can use as a base to extend for guided source code fuzzing. And there, if you feed the fuzzer with an initial set of inputs which are valid inputs, so the fuzzer doesn't need to start from scratch, I think this is the key to reach as maximum coverage of code paths and to find really nested deep bugs in the code. And if you already have unit tests and integration tests, you already solve lots of challenges, and this could really be a good starting point for conducting fuzzing in the projects across the automotive supply chain.
That makes totally sense to me. Yeah. So you are mostly, can we say, Steffen, that source code fuzzing is one thing which is mostly for, let's say, system integrators or producers of concrete components, or is this then rather topic from an integrator level? So who is actually a good target group for applying source code fuzzing?
This is an excellent question. To be honest, what we always try to achieve is to shift left in the software development lifecycle as far as possible. The earlier you find your bugs using a fuzzer, the less cost you have to fix those bugs. Back a few years ago, the answer would have been pretty simple because the automotive supply chain was kind of structured in a hierarchical way with OEM at the top and his tiers organized level by level. But today, the automotive projects became complex and you have kind of every possible combination of who is doing what. And my personal opinion is that the fuzz tests should be as close to those developer that tried also the unit and integration tests as possible, because they know their code, they know where to, when a crash happens, what the logic is behind, and how to deal with that. But that's not always possible. So the general proceeding here is as left in the software development lifecycle as possible. So if a developer of an ECU application finds a bug in his application using fuzzing, it's easier for him or her to find to fix the bug or reproduce the bug compared to when it's found during the production of the vehicle or even in the field. So better as early stage of the life cycle as possible.
Yeah, I think that also fits well into the, let's say, revised strategies of the OEMs or the whole automotive industry, right? So this shift left approach, increasing the release cycles, shortening everything, making it more efficient, more interacting. But one question to you, Marcus. So Steffen explained us about source code fuzzing, the potential impact you can have, and the possibility to find deeply embedded bugs. Where do you see the advantages of protocol fuzzing?
Yeah, I think that the advantage of protocol fuzzing, it's interesting to see that source code fuzzing and protocol fuzzing, there is always this goal of shifting left and to find bugs before. The advantages or the complementarity that I see in protocol fuzzing in this situation is that with protocol fuzzing, you can shift left when you have a virtual ECU, for instance. So it's possible to run this fuzzing in the full software of the ECU, even virtual, or when you have the ECU, physical ECU, you can do in a more late stage. It's still prototyping, but when you have the ECU integrated with all software components. And another interesting advantage that I see for protocol fuzzing is that you can also do the fuzzing in a system level. For instance, you can start fuzzing a hardware in the loop bench or even a vehicle. You can connect the protocol fuzzing tool in a vehicle and fuzz the whole systems with the ECUs at the same time. So yeah, this is how I see. I agree with Stefan. It's complementary, and this is the advantage that I see on the protocol fuzzing.
Yeah, I think if I may add one more thing, I completely agree with you, Marcus. For me, I also like to do protocol fuzzing. Was never a topic that it's either or. It both has their valid points, and while guided source code fuzzing is maybe fast and scalable, protocol fuzzing finds bugs on real ECUs. So some with guided source code fuzzing, you cross-compile code which really usually runs on microcontroller, but that's not 100% accurate. Maybe for 95% of the cases, but those other 5% where hardware dependencies matter for the logic, the protocol fuzzer is a more effective tool than the guided source code fuzzing. So it's both needed.
And this is really interesting as the industry evolve in this direction, the automotive industry, having the both techniques being applied in the software development process. I personally think is a huge advantage for increasing software robustness and cybersecurity. So fully agree. I'm very interested in actually having the opinion from you both. What the future of fuzzing looks like. What are the things that would be needed fuzzing to evolve that would increase customers' productivity and etc. So in short, how the future looks like for fuzzing.
Can I make a wish?
Yeah, sure.
So because I worked also at a supplier and now at the OEM, and I understand both sides. I think it would, if I could really wish, I think it would help the automotive industry if we use one of our many consortium to kind of share the fuzzing artifacts, so that every party in the supply chain would be able to fuzz what's most effective in their position. So if we say a supplier provides a base of a source code and OEM is developing an application or vice versa, that they have a standardized way of exchanging information that are needed for feeding a fuzzer. We have these DBC files you mentioned, Markus, which is standardized across the automotive domain. Why not extend it to be able to simplify fuzz tests?
That's a very interesting point of view. Yeah, cool. Thanks for.
Yeah, if I have a free wish, this would be my suggestion, because then everybody can do what's needed and where they are in the best position to do that, while still preserving their intellectual property, if that's one demand, for instance.
Yeah, great, thank you so much. So I think we really heard a lot of great insights. Thank you very much, Markus and Steffen. I think from my point of view, you brought very clear, let's say, you brought some light into this fuzzy topic. Yeah? You hear it again and again about security fuzz testing. As we understood, nobody can really, let's say, make it very tangible and can say, okay, fuzzing is exactly this thing. I think we have learned in this podcast that fuzzing consists of many activities. It must fit the right purpose. It depends on the setup. And having said this, our episode is slowly coming to an end. Let's have a short wrap up of our recent discussions. Markus, what are your key takeaways from today?
My key takeaway is how complementary the fuzzing techniques are. It's really needed to use both to have this full coverage or the best coverage possible. And this is what sticks in my mind, because before I had in my mind, okay, fuzzy is complementary to functional test, but my takeaway after this podcast is that even the fuzzing techniques, they are very complementary, and yeah, I'm much more sure now about it.
Mm-hmm. And Steffen, what are your key takeaways from today?
Markus kind of said already what I wanted to say. We heard two approaches. Both have their benefits, both have their constraints, and in what is needed and how effective they are. If as many parties in the automotive supply chain conduct fuzzing, I think we are all set best as a whole industry. Because for me, the security especially with fuzzing, it's not a sprint, it's like a relay race, and not everybody's running on their own. We are kind of depending on each other, and everybody should do their part to make our softwares, which at the end get into vehicles, as secure as possible.
Great, yeah. Steffen, Markus, really thank you again. Yeah, it was a very inspiring and open exchange about fuzz testing we had, and how fuzzing can be used, especially in the automotive domain. And I would really like to thank you for your time, that you could join our podcast today. Finally, I invite every of our listeners of this episode to give us also your comments on your preferred podcast platform. And also please feel free to get in touch with us directly, right? For example, on LinkedIn, by email, or whatever. We hope that we can meet you at any upcoming events in the future. Maybe we can exchange more about security fuzz testing. At least I would really appreciate and looking forward for this. Thanks for listening to our ETAS podcast today. We wish you a great day and goodbye.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.